Why did a routine maintenance cron job bring our production database to its knees with deadlocks? The answer isn't an obvious bug or a missing index. It was the isolation level we all take for granted. Repeatable read. Most developers think higher isolation means safer. You throw serializable at a problem and it's solved. But in a real OLTP system under MySQL and InnoDB, the opposite is often true. A stricter isolation level forces the engine to hold more locks for longer, and those locks cause far more deadlocks. Today we're going straight into the lock manager to understand what repeatable read actually does and why the right fix is sometimes lowering isolation, not raising it. I'll stick to the three main levels that matter in production: read committed, repeatable read, and serializable, and I'll explain each one through the locks InnoDB takes, not just the textbook anomalies. InnoDB has three flavors of locks: record locks, gap locks, and next key locks that combine the two. A record lock protects a single row. A gap lock protects the space between two index records. It prevents other transactions from inserting a new row into that gap. A next key lock locks a record plus the gap immediately before it. But the isolation level controls when those locks are taken and how long they are held. Under read uncommitted and read committed, plain selects use consistent reads, a snapshot that does not lock anything. DML statements still set record locks, but gap locks are disabled. That means no phantom protection, but also way less blocking. Now switch to repeatable read. As soon as you issue a locking read, like a select for update, InnoDB sets next key locks on every scanned index record and the gaps preceding them. Those locks are held until the transaction commits. That is the key. The duration is the entire transaction, not just the statement. A gap lock blocks insertions, but it also blocks other locking reads that try to lock an overlapping gap. If two transactions each hold gaps that the other needs later, you get a classic deadlock. Under repeatable read, the lock scope is wider than you think. Even if you search by a unique index and the value exists, InnoDB may set a record lock only, but on a range scan, it always uses next key locks. Those next key locks are there precisely to prevent phantom reads, a second execution of the same query within the transaction returning new rows. Without them, another transaction could insert a row into the gap, and your repeated select would see it. InnoDB trades off the phantom, read for locking granularity that can hurt concurrency. So what does this look like in real life? I once debugged a system where a long-running batch job and a periodic cleanup cron kept stepping on each other's toes. The batch job ran under the default repeatable read. It issued a couple of large select for update scans over the orders table, locking thousands of gaps. The cron, firing every minute, tried to insert new rows into exactly those gaps, and because the batch held the gap locks until commit, the cron would block. In turn, the cron itself held an insert intention lock that sometimes conflicted with a later read from the batch, causing a deadlock. This wasn't a theoretical race condition. The deadlock errors happened several times a day, tripping alerts and forcing manual rollbacks. We inspected the InnoDB status output and saw the conflicting next key locks clearly. We lowered isolation for the batch job to read committed. Immediately, gap locks disappeared for that session. The consistent reads inside the batch were still fine. The logic didn't require repeatable reads, and the cron could insert without ever hitting a gap lock. Deadlocks vanished. The lesson is counterintuitive. A stricter isolation level guarantees more consistency, but it does so by taking more locks and holding them longer. That directly increases your deadlock exposure. So before you reach for serializable, ask yourself whether you actually need the guarantees that those extra locks provide. The trade-off is straightforward. Read committed gives you the most concurrency. Repeatable read gives you point-in-time consistent reads and phantom protection at the cost of gap locking. Serializable adds more locking on reads, often bringing your system to a crawl. Unless your business logic demands that a range of rows cannot change for the duration of a transaction, like in ledger auditing where a second run of a query must return identical rows, you rarely need repeatable read or higher. The rule of thumb I follow: default to read committed for high-throughput OLTP. Switch to Repeatable Read only for specific sessions that require snapshot-based consistency over a multi-statement transaction, and never turn on Serializable globally. Use it with surgical precision for single transactions. So when you see deadlocks, don't just look at your SQL. Check the isolation level. That default repeatable read might be holding gap locks long after you thought the transaction was done doing work. Changing it to read committed can be the safety valve that keeps your database running smoothly, without sacrificing correctness. Thanks for watching. I hope this one was useful. See you in the next video.